Right, welcome to Preparing for IoT and IT, where we're going to talk about our all-up vision and roadmap in IoT. I'm incredibly excited to be here today. I've been coming to these for several years. We've been developing a set of technology in Azure for several years, and we're really reaching a point of maturity and capabilities that I think is really unprecedented. So I'm excited to talk to you about it today. Excited to talk about how it can be relevant to IT as well as beyond. Before we get started, first, congratulations for finding room 224. The first 100 of you got a special prize for that. The rest, there'll be some more device giveaways later on. I'll be talking about that afterwards. So why enterprise IT should care about IoT? IoT is a technique of connecting physical devices and being able to sense the real world in real time. And as central IT, if this hasn't already reached your business units, it will. It is broadly applicable to virtually every market segment on the planet. And it's going to be another technique just like mobile and cloud and all the other ones that have become very common and standard practice. We estimate about 20 billion devices will be connected to public clouds by 2020. Pretty sharp stick up from there, up to about 80 billion in 2025, generating a tremendous amount of data, generating a tremendous amount of uplift in opportunity for businesses. And so it's important to understand it, where it's going, and how to benefit from it and not be disrupted by it. IoT really plays to the strengths of IT organizations. In a lot of ways, you can think of it as the ultimate bring your own device. It's bringing lots and lots of a homogeneous set of devices or heterogeneous set of devices. And so it really does play to your strengths. The need for a strong and consistent enterprise-grade security approach. The need for data ownership and privacy, for manageability and patching and all of that. It is very important to get this right so that companies benefit from IoT and don't suffer the risks of it. There's a bunch of best practices that we've learned over the years. We've been at this for many years now, and we've seen a lot of things now, and we've started to assemble sort of best practices. And these are the things that we tend to coach customers and partners on. And as I was putting this together, I was thinking about all the different IT teams that I've worked with, and I wanted to put together some recommendations for best practices, and take it as you will. Something that we saw very early on, maybe 4 or 5 years ago, was this tendency of central teams to build standard IoT platforms. And that's problematic for a couple reasons. I mean, one of those is we have a division of approximately 25,000 developers that are building things pretty quickly. And at this point, clouds like Azure, we have really leading edge IoT platforms and a tremendous amount of momentum. And so it's much better practice to build standard usages of that and standard practices on that than it is to try to build sort of a wrapping layer or anything like that. Work with business units early. A lot of IoT innovations that we're seeing start in a business unit and wind up spreading to other business units. And so, there can really be a good partnership between IT and the business units. And to avoid the inevitable, sort of tug of war that happens once IoT starts to take hold in a business. The other thing is work with OT teams early. OT teams are really going to be, the partners in this. They're expert at, and this varies widely, the OT teams that are employed across market segments. But, we like to say that the combination of IT and OT is really what powers IoT. And so having a partnership early where you use software as an intermediary, where you're using virtual teams as a way of combining both disciplines into practices that look at, how do we secure devices, how do we update devices, how do we keep them always consistent. And then finally, learn from best practices to help the business unit succeed. Something that we're starting to see much more of, which is great, is the development of business strategies first before technology strategies get deployed. It's a really important thing. What are you going to do with IoT? What is the business case for it? What is the return on investment you expect? What is the margin? What is the data that you're going to be collecting? What is the market value of that? All of these things feed into the business strategy. And the more you can help the business units with this, the better. Making sure that in business units there is clear executive support. I can't overstate that enough. As IoT is a transformative experience for most companies, and it really does require strong executive will in order to, especially for the early years. And then I think probably the most important is to implement a crawl, walk, run approach. We've seen moonshots fail, and we've seen very modest solutions really pick up steam. This crawl, walk, run approach where you take a pilot and prove value and recover revenue, and then move on to more sophisticated ones, builds confidence in the organization as it benefits along the way, as opposed to waiting for 2 years later for a solution to be super power and capable and all that. Because what can happen in the intermediate time is people start to question, are we really getting what we think we're going to get out of this? Versus in an iterative approach, that doesn't happen. So when you step back and think about IoT, one of the things that I wanted to make sure that to leave you with is that it's not just about connecting devices. It's much, much more to it. IoT is about enabling something we call a digital feedback loop, which sounds like a marketing term, but it's really not. What a digital feedback loop is a technique that winds up connecting large parts of your enterprise or of your operations, your products, the people, your employees, your customers. The reason why it's called a feedback loop is because it's not a one-time thing. It's not like you just connect to your operations and then you walk away and you're done. What you learn from your operations today is what helps you optimize them tomorrow. What you optimize tomorrow helps power new insights and new optimizations that weren't possible on the first time around, that digital feedback loop. We have watched this now a number of times with very early customers. What they started out doing in IoT and these digital feedback loops is not what they're doing now. And one of them said it best. He said he likes to counsel his other colleagues that every day you're not part of this digital feedback loop, that you're not developing this technology. You're not losing 1 day. You're losing 2 the first, and 4 the second, and 8 the next, because the power that it creates is really exponential. Our vision is to help customers, companies, and partners take advantage of this digital feedback loop. And when you sort of blow up a digital feedback loop, what you see is this sort of blend between 3 things. There's things, insights, and actions. There's things that are sending data, that are receiving commands. There's insights that you gain from that. And then there's informed actions, which in turn lead to better things and better processes. Most companies, Microsoft included, have breaks in their digital feedback loops in various places. No one is perfect at this, no one. And yet it's important to get better and better and better over time. We have as a company, we have gotten better to dramatic effect, gotten better at taking advantage of this digital feedback loop. And part of that is large portions of businesses aren't digitized. In particular, service organizations aren't digitized. Production and operations aren't digitized. And yet as they become, it provides an opportunity to save, first of all, to save a lot of money, and second of all, to create market-powering insights that lead to new businesses. We have seen over time that there's 3 stages traditional companies go through in their IoT journey. And many of our top customers you can plot in different places on this, and you can actually watch it change over time. The majority start at the very beginning, which is connect and monitor, and that's where you're simply connecting a device, knowing whether it's operational, knowing where it is, knowing whether it's left a geofence, knowing whether those quarters that got deposited into a vending machine actually made it to the bank. Those kind of things that ensure basic human decency are often employed as the first part of IoT. And then that starts to lead to, as you're collecting that data, to the next stage around analyze and improve. And that's where you're able to take signal from those devices and analyze it and find those new insights that lead to predictive maintenance, operational efficiency, zero downtime or zero unpredicted downtime, that lead to connected products where you understand how your customers are using those and provide a very profound relationship with your customers that weren't possible before. And then the last stage we call transform and expand, because what we see there is customers expanding businesses and transforming their businesses. switching from selling service contracts to selling uptime guarantees, switching from selling devices to selling devices as a service, starting to realize that the data that I'm collecting has market value, and it's useful in partnerships, and that data is, in fact, an asset, and that it has market value in partnership with other businesses adjacent to me. And what's interesting is that as you look over time, that value curve, that customer value curve, there's an interesting thing that happens right now, and that's happened in early stage IoT, and that's that the knee of the customer challenges happens right when the value is the lowest, right in the very beginning when you're connecting and monitoring. And that breaks into a couple challenges. Number one is investment challenges. Who's going to work on this in my organization? How much is it going to cost? What can I expect to spend on it? What's my return on investment? Technology challenges. Which providers should I use? How quickly can I assess them? How can I build a pilot as quickly as possible? And then inevitably, as customers realize, oh, it's possible to do this, then they start to go through what we like to call digital transformation challenges, which are, again, sounds markety, but are not. It's as I start to become digitized as an organization, what challenges does this produce to my employees? As an example, some of our customers that have gotten good at predictive maintenance of assets invariably have some crisis where the service technicians that were the predictive maintenance engines suddenly start to realize, wait a second, am I going to be obsolete by software? And they're not. It's very much an assisted. AI and cloud is assisting them in doing their jobs. And as they make their way through, what we're finding, some of those customers that have created very compelling remote monitoring, predictive maintenance solutions, what they find is that their service organization feels a newfound sense of pride. It feels like they're on the cutting edge. And it's actually made it easier for them to hire service engineers than it was before. That was unexpected. That was something that we didn't see until later stage. But all of these challenges happen at the very beginning. We are very committed to democratizing IoT and to simplifying it. We've made a public statement recently that we are investing $5 billion over the next 4 years. That's on top of the $1.5 billion that we already have. And that's everything from research and development, teams like ours that are building all of the products. That's our partnering programs. That's ecosystem programs that we're doing. We are serious about this because we see this as very much a real and powerful wave of computing that is going to sweep across lots and lots of enterprises, and we want them to be able to benefit from it and not be disrupted by it. We have a lot of great momentum right now. We were recently recognized by Forrester in their Industrial IoT 2018 wave as the only hyperscale cloud provider in the leader category, which is the best one. And that sort of speaks to the amount of momentum that we have, the service offerings, but also the ecosystem that we've built up and how we help partners succeed. Microsoft is very much a platform and partnering company, and some of our partner programs are really unparalleled in the industry. So a lot of great momentum with a lot of great brands that are in production. So enabling that digital feedback loop that I was talking about that looked really simple is actually a little more challenging. It used to be challenging. And we've been busy at work over the last 5 years simplifying it, building out powerful capabilities, and then making them very, very, very easy to use. And I'm going to show you some examples of that. So simplifying in a number of ways that we're going to cover today. Easy to build, secure, scalable solutions all the way from device to cloud. Once you have a solution, to be able to provision devices in mass. This is an often overlooked problem area of IoT. If you have a scalable solution set up and you go to provision 1 million devices over a few months and you're doing it manually, you're not going to get 1 million done, right? You need a way of automating that. To secure and manage devices at scale. If you're driving trucks around to do troubleshooting of devices, you're not going to have a great IoT experience. You need to be able to do it remotely. To find insights so that typical knowledge workers can find insights from IoT devices over petabyte scales. And even to run cloud services in edge computing scenarios right down on devices. All that making it easier to benefit from IoT. So I'm thrilled to announce that we are now generally available with Azure IoT Central, which is our SaaS offering for IoT. This is a culmination of many, many years of work on our part. So first thing we did is built out a huge set of hyperscale cloud capabilities. and solution accelerators. And now we're to the point where you can get started very, very quickly with IoT Central. Fully managed SaaS offering requires no cloud solution expertise. So it's a configuration-only system, though it does have extensibility points that I'm going to show you as well. Built-in security best practices, built-in scalability. We wear the pager, you customize the app. You own the data, you own the application. The other thing I should very much mention, it has a very simple pricing model. So it's a per-device pricing model. We have a free trial, which is 5 devices. You don't even need an Azure subscription to try it for 7 days. And after that, you can try it with 5 devices or less for as long as you'd like during development. So it's a very, very easy way to get started with IoT. And IoT Central helps you do a number of things. Number one is get results fast. I'm going to show you that in just a second. Not worry about scale, not worry about security, and be able to grow with your solution. And then to provide enterprise-level integration. You know, if you think about an IoT solution as being that, comprised of that digital feedback loop of things, insights, and action, IoT Central is geared towards accelerating that, managing things, monitoring things, be able to find insights from them, and then drive informed action with business process integration. In addition to the things that I've talked about, it provides device connectivity and management. It's easy to create monitoring rules and trigger actions, and a rich set of extensibilities. So with that, I'm going to go ahead and do a quick demo of IoT Central. So I'm going to pop out over here. So if you do a quick web search for IoT Central, it'll take you here, and it tells you all about it. There's a little video that explains what it is and what it does. And if I go ahead and click Get Started, this will show me all of the IoT Central applications that I've got. So if I create a new application here, I can choose from a free one or a paid one. So I'm going to pick a free one. And note, I'm not putting in my Azure subscription. And I'll call this Sam Contoso Ignite. And we have a couple different application templates, one for our developer kits, a blank one if you just want to get started, and then a Contoso application which shows a simulated chilled refrigerator. So I'm going to go ahead and click Create, and that's going to go about provisioning an application. Now, what it just did, so that was somewhere around 15 seconds, what that just did is go and provision a set of Azure services under the covers. IoT Hub, time series insights, Azure Kubernetes cluster, Microsoft Flow, a bunch of services that were just provisioned. And they were all ready to go, so all you had to do is go allocate an application. So it's a very, very quick way to get started. And so if I want to start customizing this, I can go into the dashboard, so I can go into my Device Explorer. And let's say, for example, that I wanted to start turning this from a refrigerator into something else. Could, for example, just go upload the image of a generator, and then maybe start removing some telemetry, adding some state, and things like that. And it enables you to model the data that your device is going to be sending, and then to be able to set triggers on it and drive informed actions. So I'm going to do this Julia Child style, and go pull one out of the oven that's already been baked. And so this is a Fabricam IoT demo. And what this is, by the way, this took us about 2 hours to put together. So it took us 15 minutes to provision it. It took about 2 hours to put all the dashboards together. And if you look, IoT Central has a Device Explorer. It has a notion of device sets, which are devices, subsets of your devices that you care about, the ability to perform analytics, to perform management jobs, and then some capabilities for application building. And if I look at this, I'm going to go ahead and I can see all the different devices that I've got. I can click on one of these devices, and here I see all the different data that it sends, all the different telemetry, the different states that it goes through, the different significant events that it raises, and I see all it plotted along a line. If I want to look at this data in a grid, I can. If I want to look at it in a chart, I can. And if you'll notice, I can see all the different states that this has gone through. The engine is being off, and the engine being idle, and the engine on. And I can see significant events, like if I click on this one, I see an engine failure occurred at a certain point. I have settings on the device that I can set, and this will help me perform device management operations. I have properties that the device sends, as well as properties I can set on the device. And importantly, I have commands that I can issue to the device, for example, rebooting it or checking its firmware version. And then importantly, I have rules. And so I can go into, for example, watch for temperature. And you see some of the spikes. So this is simulated data. There's another thing that we do is we provision these IoT Central applications. When you create a device, you can simulate it. And so you can model the entire solution before you even connect a device. So in this case, we have a simulation. As you can see, the temperature is spiked a few times. So if I want to set a rule and go perform an action like send an email or an SMS or open a Salesforce or a Dynamics 365 or an SAP record, it's as simple as creating this telemetry rule. I can pick aggregation, so I can look for average increases over rolling windows, and then go perform an action. So if I go ahead and edit the template, and what that does is it edits all devices of that type, and then choose an action, you see I have a set of actions, and I can trigger an Azure function. So here's some of our extensibility. I can trigger an Azure function. If I'm using a webhook somewhere off on the open internet, I can call a webhook. I can send, we have a simple email template. And more importantly, I have a Microsoft Flow. So if I click on Microsoft Flow, that'll take me to the Flow workflow. And I can connect to the more than 220 different services that Flow supports. I can open up records in Microsoft Teams or Slack, in Salesforce or SAP. I can send email. I can send pagers. I can do all sorts of interesting workflows triggered just simply by devices hitting a certain condition. And then, of course, I can create users, track users, and manage roles, manage my billing, and even export data. This is an important thing. So you can set up continuous export to the Azure storage account of your choice, which enables you then to go and perform analytics over the data that's coming from IoT Central, both all the device data as well as the application metadata. And then that enables you to do things, for example, like use our Power BI template. So if I click on this, this brings up a Power BI template that we did. Now, why would you use Power BI? You use Power BI because if you have lots of these applications and you want to track all sorts of state across them, for example, how many alerts am I getting and how long did it take my service technicians to do those? What's the type of devices that are having problems and things like that? So IoT Central is fully extensible with rich business process integration as well as Azure integration. And we're really just getting started. So to help you see where this is going, we thought it would be useful to bring up one of our very important partners, a company called Arrow. And with that, I'd like to welcome Ashish Parikh to the stage. Ashish, come on up.
Thanks, Sam.
Great to see you.
Good to see you.
So just for the sake of the audience, tell us a little bit about Arrow and what you do.
Yeah, most people probably haven't heard of Arrow Electronics. We're 83 years old, founded in 1935 in Manhattan, selling radio kits. It was the killer app back then. And alongside this company, I think most of you know, called Radio Shack. We've continued to innovate, really started in distribution, but really evolved into a technology and services company at this point. And really, that's been the evolution. We're a Fortune 113 company and been a Microsoft partner for about 15 to 20 years now.
Right. Well, let's go through a little bit about what you do in IoT.
Yeah, so really IoT is a journey we've been on for about 6 years. Started when most people didn't call it IoT, we called it M2M. And from our heritage, there are a couple of pieces there. One is on the component side, the electronics that you need to make things. And we've been helping customers build these things for a number of years now. And we have over 150,000 customers that are building things. And again, what do they need to go build those things? So how do we help customers create, connect, analyze, manage, and sustain secure connected devices throughout their life cycle? And there's a product component. We have access to over 800 different vendors and their technology to go bring that together. So whether it's a small sensor or it's Azure Cloud and the analytics, again, we can bring all of that together to help customers build solutions. Or if you're an IT organization and you want to use it, we also have completely packaged and ready to deploy sensors that you can use. And there's a big difference there. Yeah. A lot of people struggle with science projects. Here's a Raspberry Pi with apologies to Raspberry Pi. But a lot of people start with that. But the challenge with that is it's not scalable. much like you talked about a few minutes ago about people kind of build their own IoT platforms, it's the same thing. You're not able to go scale those solutions. And really, where we come in is how do we help customers scale? So we can take all the technology elements, and we can bring a whole lot of services together. So the engineering services to go build and integrate products and solutions, as well as, how do you connect them, both from a network perspective. There are a lot of different network options out there. It could be cellular. It could be satellite, depending upon where you are in your application. If it's an oil rig, you may need satellite there. Or you may have some LP-WAN like LoRa or Sigfox as options as well. So there's a lot of complexity on the device side of the world, and we can basically help with the engineering around that, and then, again, bring on the integration and the analytics. What we find is a lot of people claim that's the end, right? I've analyzed the data, I've got a dashboard. But I think if you look at the long life cycle, that's where the challenge starts. Now you need to think of how are you going to manage and monitor these devices over the long period of time? How are you going to manage the platform? And these are complexities that a lot of customers are grappling with. And then last but not least is sustain, which is if you're going to have, you said 20 billion devices?
2020, yeah.
In 2020. What happens in about 5 to 7 years when those 20 billion devices now need to get replaced? From a security perspective, as well as a sustainability perspective. You need to make sure that you have a strategy up front, otherwise you're going to be in a lot of trouble. And again, we can bring all these capabilities together for our customers.
So tell us a little bit about your experience with IoT Central and where you see it fits in with helping you.
Yeah, so,
And what you were doing before.
Yeah, what we found is a lot of customers were taking Azure PaaS services and saying, okay, we're going to go build a solution. What we found was it was taking them a lot of time to get to what Sam was able to show in, with 2 hours worth of effort. And so it's really bringing all this stuff and simplifying IoT, right? IoT is complex. The devices, there's nothing. So IoT is complex, so if anyone says it's not, they're kind of fooling you. And the complexity comes around because there's so many different technologies you have to wrestle with. And the more you can do to go abstract that complexity, the better off you're going to be. And I think IoT Central is one of those key applications that really simplifies it for you. And so the reason we have the arrows pointed at connect, analyze, and manage is, again, when you think of the device connectivity, you have to go connect the devices. You have to go think about that. IoT Central has made that easy. When you think about analyzing the data, setting up the business rules, again, Sam just showed how that's become a lot easier. And then the last piece is the manage. You don't have to worry about managing the application, the continuous development cycles. You worry about your application. You don't worry about the infrastructure. Much like you use, Office 365, you don't think about what's sitting in the Azure cloud. You just use the application. Yeah. Same thing here.
Good analogy. So what's next for Arrow?
Well, we've been working very closely with the IoT Central team, and we're really pulling together segment-based solutions. So here's an example of an energy monitoring solution. It's something that we've deployed at one of the MTCs. And again, you've got an IoT Central dashboard, but in order to get the data there, you need a sensor. So on the bottom left, what you see is a little device called a Power Scout that hooks into an energy panel. So if you wanted to go monitor energy utilization in a building, and I always say every business has buildings, and not every building is LEED certified. So how are you going to get in front of the waste that occurs? How do you get better insight? And how do you take that data and then maybe negotiate with your utility around some dynamic rating? So you take that. You now need to take that data and process it through a gateway. There's some edge compute, some local processing that happens. And then chances are IT is not going to just let you connect to the network. And in some instances, you may want to connect via cellular. And so what Arrow is doing as an IoT solutions aggregator is really bringing all these things together. And the term IoT solution aggregator is one that Microsoft has put on us, because we're able to go pull all these different pieces of technology and solutions together, so that when you're trying to do this, you're not going to try to procure a Power Scout from vendor A, a multi-tech conduit from somebody else, a cellular service for data from a third party, and then get your Azure IoT Central subscription from a fourth party. Basically, we're the party that you can come to, and we can do this. So this is the starting point.
Great.
We've got a number of other things for different segments in smart cities, retail, that are coming up next.
Awesome. Well, thank you so much. We appreciate the partnership.
Yeah, thank you.
Thanks for your support. So I have a chart of all the different solutions or all the different services that we have now, and it's an eye chart, so I'm not going to show it to you. Instead, I want to focus on 6 different things across the spectrum. The first is in the intelligent cloud. We just talked about IoT Central. There's another offering that we have, which is solution accelerators. So if you think of these as 2 ends of the continuum, IoT Central, as we just talked about, is a fully managed IoT SaaS offering. We also see some customers want the full power of being able to use the Azure services directly, but don't want to start from scratch with an IoT solution. Now, we have IoT solution accelerators and a set of solution accelerators like remote monitoring and predictive maintenance and connected factory and things like that to help you get started quickly. They're both built on the same IoT services. They're both use the same reference architecture, and they have a set of extensibility points. And in our roadmap, these really form a single continuum for accelerating IoT solutions. Of course, on one end, fully managed SaaS offering. On the other end, it's in your subscription, but you don't have to start from scratch in order to build it. Our solution accelerators are fully open source. They're up on GitHub under an MIT license, which means you can do whatever you want with them. You can take them, customize them, brand them, sell them, knock yourself out. They're really for you to accelerate your journey. And we also have a reference architecture that we've published that talks about our different IoT services, how to best put them together, best practices to make sure that you have a great experience using Azure IoT. Both Azure IoT Central as well as Solution Accelerators use a new service that Azure's got, Azure Maps. And what Azure Maps is an offering that has everything from mapping controls all the way to geospatial APIs that help you do everything from search and geocoding to traffic information, time zone detection. And one of the reasons why we're investing in maps is because things exist in the real world. Location is very important in IoT, not just for things that move, but also for fixed things. And so we've now deeply integrated Azure Maps. It's also available as a standalone service. Our platform services, there's a couple really interesting ones that we talk about. Azure IoT Hub is our cloud service gateway. This is what you use for connecting the world of devices to the world of the cloud. It is used by Azure IoT Central as well as the solution accelerators. And for customers that want to just build everything themselves from scratch, it's a great service to start with. So it does everything from bidirectional communication across a number of standard open protocols to enterprise scale integration with downstream systems. So for example, if you want to take IoT device data and route it through a Kafka cluster, for example, you could do that. And it provides a rich set of end-to-end security. And then we also have a peer service called the IoT Hub Device Provisioning Service. This is a separate service where you can go and pre-register devices, and when those devices wake up and contact that service, it'll register them with the correct IoT hub of your choice. So this really helps you create one set of devices with one SDK on them and register them with any, at runtime, associate them with any IoT solution that you want. Both IoT, Azure IoT Central, as well as the solution accelerators use this service as well. There's a bunch of new capabilities we just announced today, from automatic device management. There's talks this week about all of these, so I'm not going to go into a lot of detail. We just did do some advanced message routing, which is taking messages coming from devices and automatically splitting them and sending them to downstream Azure services. We've had that capability. Now we're allowing you to do it based on device twin metadata. And we just announced Android and Android Things support that join our support for lots of different versions of Linux, Windows, real-time operating systems, embedded systems. One of the things we like to point out is we support the full open ecosystem of IoT devices. This isn't a Windows-only play or anything like that. And so we see a lot of heterogeneity in IoT, and we think that will be the case for years to come. The device provisioning service, we just added a ton of features to it, increasing the number of limits, adding high availability with geo-paired regions, a whole bunch of neat features for provisioning, from symmetric key attestation to automatic re-provisioning. So if you want to move a device from one solution to another, we make that really easy. And even custom logic using Azure functions. So at runtime, when a device connects to the device provisioning service, we can call your Azure function, and you can decide not only which IoT hub it should go to, but which properties it should have on it by default, which enables you to trigger your device management workflows. So super powerful features. So IoT Edge, talking about the intelligent edge. IoT Edge is a platform that we made generally available this year. And what IoT Edge is it's a new take on this pattern of IoT. So if you look at things, insights, and actions, the typical flow of data in IoT is you have things that are sending data to the cloud, you analyze it, you find insights, and then you drive informed actions. Sometimes that action might drive signal back out to the device. What edge computing is the ability to take things that were running in the cloud and have them leave the cloud and then run right down on devices, and yet be able to manage them and have them run in controlled loops. And so, for example, if I'm doing predictive maintenance on something and I want to make sure that predictive maintenance keeps running on device, I no longer have to be an embedded developer. I can simply take an Azure service like machine learning, export it to a container, and run it right on an IoT device, running IoT Edge. And so this is where IoT Hub and IoT Edge work in harmony to enable edge computing. It is an open source runtime. It runs on both Windows and Linux, and it's been open source since the day we went general availability. At a high level, the way these topologies work is you can have any number of IoT devices connected to IoT Hub. You can also have IoT devices that are running this special middleware called IoT Edge connected. We track those separately because you can do things with IoT Edge devices that you can't do with IoT devices, like run these workloads on them. And then you can use IoT Edge in gateway configurations, of course. And so you could have millions of devices connected to an IoT Edge device if you wanted to on a factory floor, for example. The way a deployment works is that we've gone around and taught these different Azure services like machine learning and cognitive services and Event Grid and even SQL to export themselves to containers, which enable you to place those certain functionality in a container registry and then author a deployment manifest. A deployment manifest indicates what is the deployment or the runtime that's going to be running, which is typically a set of containers all interrelating to form processing pipelines to achieve something. So as a deployment manifest gets sent down to the device, that in turn causes it to turn around and download containers from a container registry. Many times these containers are private in your subscription, so these aren't available to other companies or anything like that. This is all your private deployment. Now, the reason why we do this is containers wind up being a great unit of portability between cloud and edge. You can run them in either place. It also means that it's easy to manage with this approach. It's easy to manage millions of IoT Edge devices. And in fact, we've extended our device management to not just work on the device that IoT Edge is running on, but each individual container. So for example, if I want to manage how a machine learning model is running in a container, I can do that with a simple JSON property in the cloud, transmitted down to the device, and update machine learning models across huge fleets of devices. It even works with the device provisioning service, and what this means is that you can pre-register an IoT Edge device with the device provisioning service and tell us which IoT hub it should get registered with. When it wakes up and communicates with the device provisioning service, it will register it with the right IoT hub, which will then cause it to download a deployment, turn around and pull down those containers. And so you can literally just turn the device on, and it'll go operational and go through a device management workflow, all without touching it. So it's a great, great, great feature that helps you get going with edge computing. So I'm thrilled to announce that we announced at Build the Vision AI Developer Kit in partnership with Qualcomm. I'm thrilled to announce that it's shipping soon in a matter of weeks. There's a sign-up page. You can sign up here if you want to get them. It's a pretty neat device. So this is the device here. It's about this big. and you can see it can recognize some objects. We're still training it. It thought a laptop was a chair, but we're still training the model. I haven't tried this yet, but let's see what happens. Oh, there's a TV monitor. So what it's doing is it's running a AI model that was generated using Azure Machine Learning that takes advantage of the hardware capabilities on the device, and it can perform that inferencing at a very high frame rate, about 30 frames per second. And so these will be available as developer kits here very soon. Also, a shout out to Arrow. Arrow is the one that's going to be distributing these and providing the inventory for them. And so huge thank you to the partnership with Arrow on these. Okay, moving on. So there's some great new capabilities with IoT Edge. The general availability right now is that IoT Edge needs to be connected to IoT Hub to pull down new workloads and to be able to do manage device identities, not just for the device itself, but also any downstream devices. And one of the biggest requests that we got after we made it generally available was for offline support. And so we're thrilled to announce extended offline support, so you can have indefinite offline. If I want to connect an IoT Edge deployment to IoT Hub and then cut the network cable and have it run indefinitely, I can. You'll be able to do that. That even means that downstream devices can authenticate because we cache all the device identities right in IoT Hub, and it enables a trusted brokered relationship between downstream devices. So that's available now in preview. We also made Azure Marketplace updated for third-party modules. Now, what this is what we're seeing is this concept of taking a container-based approach to edge computing is super powerful. And what we've been hearing from partners is that they have certain functionality that they've packaged up in containers that they want to make broadly available for other third parties to use and eventually to sell. And so we've started a marketplace of these. And if you think about in cloud, there's marketplaces for VMs, there's marketplaces for containers. Makes a lot of sense to have containers for the edge as well. So we've started that. We also now support a new service in IoT Edge, which is Azure Blob Storage, which means you can write to blob storage just like you can in the cloud. It's the exact same API in both places, which is super useful for store and forward operations. We already had Visual Studio Code tooling support. We now have Visual Studio as well. We support Azure DevOps as well as now Jenkins for CI/CD support. So you can go from everywhere from checking in to a test deployment to a live production deployment triggered in a CI/CD pipeline. And then we're announcing that in development we have high availability multi-device support so that you can actually create clusters of IoT Edge devices in high availability configurations. All right, Azure Sphere. I'm going to go quick here because we've got a lot of content. So Azure Sphere is our new offering for microprocessors. If you look at those 20 billion devices that are going to be connected to public clouds by 2020, or the 80 billion, approximately, our best estimate is approximately 3/4 of those are microprocessors. Not higher level like Windows and Linux boxes and things like that, but are microprocessors. And when we looked at the microprocessor space about 4 years ago, we found a shocking lack of security techniques. We found that development was still fairly laborious, and it really hadn't evolved in about 15 years, and we thought that was a problem. And so we just recently announced earlier this year Azure Sphere. And what Azure Sphere is a breakthrough new offering that's actually three things. That form an end-to-end offering. The first is it's certified microprocessors. Specifically, it's chip IP, ARM-based chip IP, that has all of the different security techniques that we've perfected over the years with our products. That we've learned the hard way in many cases, all the different things that need to be present in a device, coupled with a new Linux microkernel that Microsoft produces, supports, and services that runs on that. The Linux microkernel runs in about 2 megabytes of memory. It's super, super tiny. And it runs on these devices. These devices are actually tri-core chips, so they have real-time operating systems on them as well in the other two cores. And then the last is the Azure Sphere Security Service, which monitors the worldwide fleet of Azure Sphere devices, which looks for tampering, which can signal you in one part of the world. If a device is being tampered with, we can signal everybody We can provide updates for it, and also will alert you that an update's available and allows you to control rolling out the updates to your Azure Sphere devices. So if you think about it from the point of view of like if I'm producing connected appliances, I know a lot about how to produce an appliance. I don't know a whole lot about how to secure it. And that's a very, very important aspect of creating connected products. And so Azure Sphere is an offering for the very, very tiny devices out there. We've also produced some leading-edge Visual Studio and Visual Studio Code support for Azure Sphere, which makes it super simple to write code, to debug it, to have a great experience that's very unlike traditional RTOS development platforms. And we're thrilled to announce that today we are making available for public preview the first of the Azure Sphere development boards. They're being produced by Seed Studios. And this includes the availability of the Azure Sphere operating system, the Azure Sphere security service, as well as Visual Studio tools for Azure Sphere. So you can go to www.azure-sphere.com to learn more and order boards. Windows IoT. So on the high end of devices in capable scenarios, what we see is a need for an always up-to-date offering. So Windows IoT has been out for a few years, and we're thrilled to announce that we have a new service called the Device Update Center, which enables you to control the updates to your IoT devices running Windows IoT. We also have security services that are based on the exact same security services in Windows to keep those secure, and we just announced 10-year security-only updates for Windows IoT. And so instead of getting feature updates to your IoT devices, you can simply get security patches. And again, you can control when you get them. It's a great offering. So of those 6, there's a lot of capabilities, but I wanted to talk about 2 really interesting new ones that are very important. If you think about IoT from an IT security perspective, IoT, of course, as we were talking in the beginning, can be pretty challenging. There's a diverse set of devices running different operating systems. There's new threats that are constantly emerging. And you're not just securing a cloud deployment, you're securing a cloud and a set of devices and the connection to those. And so you really need a single pane of glass across all of that from a security stance perspective. So with that, I'm thrilled to announce the pending preview of Azure Security Center's IoT support. And so Azure Security Center is going to be building integration with IoT Hub as well as all of our SDKs and Azure Sphere and all the other ones to enable rich security guidance and monitoring across a heterogeneous fleet of devices. So it really turns it from this picture into that picture. It really helps ensure security and integrity across the entire fleet. And it's not a passive system, it's an active system, which is constantly monitoring for threats worldwide, using signals that we get through our security center, and then broadcasting those. And for that, I'd like to show you a little demo. So,
Azure Security Center is adding new capabilities to help protect IoT. The great thing about having these features as a part of Azure Security Center is that it helps IT security and the CISO's office see suggested security posture improvements, security alerts, and potential remediation all in one place. This is one of the ways Microsoft is simplifying the process of integrating IoT into your organization's IT. Let's dive into how Azure Security Center will help protect IoT. Azure Security Center provides end-to-end protection of your IoT environment. It automatically detects what's included in your IoT deployment and starts monitoring, but you can add or remove resources manually as well using this Resources tab. In the overview, we see our entire IoT deployment. When many people think of IoT security, they focus on devices, but cloud services, the cloud gateway or IoT hub, and IoT admins are also important attack vectors that must be protected. In the Recommendations tab, Azure Security Center shows recommendations for improving our security posture. We take advantage of Microsoft's unique threat intelligence to ensure your IoT deployment meets security best practices developed across Microsoft and worldwide across our customers. The recommendations are sorted by importance so you can prioritize the most important actions. When you click on a recommendation, you see a description of the problem as well as recommended remediation steps you can take to solve it. While recommendations help you know how to improve your security posture to avoid risks, alerts make you aware when something risky has already happened so you can respond. These alerts are also sorted by importance and cover your entire IoT deployment: devices, IoT hub, connected cloud services, and IoT admins. That way, you can ensure all parts of your solution are protected. When you click on an alert, you see a description of what went wrong, as well as recommended remediation steps you can take to solve the issue.
Awesome. So Azure Security Center will be updated in the coming months with this capability of protecting IoT devices. And the last thing that I want to talk about is a really interesting new topic, and that's the evolution of IoT and something that's been happening over the last couple years that we're now announcing support for. So when we look at early IoT solutions, a lot of them were really geared towards managing sets of devices, large lists of devices that were homogeneous, where you were predicting their maintenance, be it elevators or factory equipment or water pumps or whatever. And there's a tremendous amount of value in those, especially as you get into predictive maintenance and optimization. But a lot of those are very, again, it's managing flat lists of devices. And what we started to see over time was that customers, as they were managing those flat lists of devices, started to want to model the environment those devices lived in. We also were spending a lot of time recently with a bunch of partners in the smart spaces and smart energy sectors and seeing what emerging needs were there. And especially in smart buildings, what we were seeing is that there was very much this need and sort of a natural desire to model a building first and then connect it, as opposed to connecting it and then modeling it. And so we found this approach, working with our customers, to be quite natural. I'd say the majority of the innovations that we bring to market come from direct customer and partner interaction and watching what they wrestle with or watching what they're trying to do, and then trying to be the best cloud provider to bring that forward. Which brings us to the topic of digital twins. So digital twins is not a new concept. Digital twins has been around for quite some time. Digital twins actually started way back in the 80s with NASA with this concept of a real object and a virtual object, and to be able to track the state. And one of the things that denoted this is that sometimes those real objects were connected to their backing data, and sometimes they weren't. Over time, what we started to see was, like in 2000s, what we started to see is companies taking this notion of a digital twin and realizing, hey, you can start to do simulation and modeling with this, and seeing how it's going to change over time. And so digital twins got more and more sophisticated. And then in around 2014, 2015, what we started to see is this notion of connected IoT assets, be those industrial equipment or cars, very complex pieces of equipment where the digital twins were quite sophisticated and weren't as simple as a single device, but were really composite devices. Locomotives is another example, where they were composite devices. And so it wasn't simply modeling a device, but it was modeling interactions of sub-devices. And we were very aware of this trend, but as we were working in the smart spaces area, we started to see that there was this forming need to evolve digital twins, this notion of digital twins, from meaning a thing to meaning an environment. And so what we've done is we've created a new offering that helps any enterprise model any physical environment, not just the things in it, but everything in the physical environment. And if you think about this fusion between the physical world and the digital world, crossing from systems to processes, there's already this notion of connecting devices. Then people interact with those devices, and people interact with those devices in spaces. And so this notion of things and people and places all interrelated is a very powerful one that can lead to a breakthrough set of innovations that we found really, really resonated with our early partners in this space. And so I'm thrilled today to announce a brand new Azure service called Azure Digital Twins that enables customers and partners to build next generation solutions, starting with the modeling of a physical environment first, and then being able to connect devices to it, or connect data from different systems, or connect signals from people, and then to model how it interacts. It's a system that's a runtime system or a compute system that tracks not only this digital model and enables you to build it up, but tracks changes to it. So it has this notion of an extensible twin object model where you can not only track all the digital twins in a system, but how they relate to each other. So if you were, for example, going to use Azure Digital Twins to model this conference center, you could create a model of the entire area with roads and the buildings and all of the infrastructure, and then the individual buildings themselves, and then connect sensors to it and those sensors then make the model come alive. So it is a living model, and that's one of the things that's super powerful about it, is not only can you create this model, but you can make it come alive with IoT devices as well as other types of data. And then when the model starts to come alive, then that model starts raising events. And as it raises events, you can have serverless code take advantage of those events to implement business logic. As an example, if you're doing a building maintenance scenario and you want to make sure to bring down the HVAC and the lighting when people leave, you can simply respond to an event in the digital model that indicates when the room has gone idle, or conversely, when the room is filled up again, and then implement business logic in it. It's a fascinating service because it really is, some of our partners have said it best, it's very obvious in hindsight. But it wasn't very obvious until it sort of came to life that there was a need for this. And it's broadly applicable across buildings, across grid and utilities. That was one of the signals that we had, that it was much more than spaces, was to watch customers and partners starting to apply it to way more domains. And so Azure Digital Twins will be in preview here in just a couple weeks. And it enables modeling of many, many things. But we thought what we would do, because it's an easy way to understand what Azure Digital Twins are, is to talk about how it's relevant for smart spaces. Being able to model it, to have live data, being able to attach individual nodes or individual twins to blob storage so that you can store CAD diagrams or individual maintenance models or history of them. Azure Digital Twins also seamlessly integrates with other Azure data and analytics services, so that as the digital twin is accepting new input, it can automatically then route it to Azure data and analytics services so that you can track the history of the digital twin system as well as predict its future. And that's how you can start to take advantage of some of those simulations. So it's a very powerful system. And there's no better way to tell this story than to talk about it through the lens of one of our early adopters of this. And for that, I'd like to show this video first, and then I'd like to welcome the gentleman next.
As an elevator company, we are testing not only hardware, but we're also testing our thinking. For years, there was no change in this industry. With the help of Microsoft and Willow, we are on a different stage.
The Willow Twin is our feature platform. We're looking at the whole city and how we can leverage AI, IoT, and cloud and bring it into one solution that's robust, safe, it's secure, and it's scalable.
What Willow does is provide a digital twin replica of the built environment to bring together the static information that's produced during the construction of these buildings and the live dynamic information as well. We're leveraging the Azure Digital Twins platform because of the flexibility and scalability that offered.
The digital twin of the building enables us to do testing in a digital world instead of the real world without doing physical testing. This is the first time that we have a complete building with all the infrastructure.
There's over 15,000 live data points on that building. There's over 57,000 static data points, and I can find them at a click of a button.
It won't be very long before every single building construction process ends up with a requirement to have a digital twin of the asset.
The amount of information that we can now capture through the Azure Digital Twins platform is mind-blowing. Data from an infinite number of sources. So together with Microsoft, we will change the built world.
And now I would like to welcome up Joshua Ridley, who is the co-founder and CEO from Willow. Joshua.
Great to be here.
Welcome. So tell us a little bit about Willow, who you are, where you came
Just
from.
follow this up.
Yeah. Well, I started the business 7 years ago in my now daughter's bedroom. I've got 3 children since starting the business, so it's been a long journey. Willow's a technology company. We have been in business in the built world for that period of time. We have expanded the business from its headquarters in Sydney to most of the major markets here in North America and in Europe. And we're working with some of the world's most admired and largest real estate and infrastructure network owners. So landmark projects such as the one you've just seen that have showcased some of our work. We've got around about 85 projects on the platform now and growing. Yeah. And it's great to be here, Sam.
Excellent. Well, why don't you log in and show us how it's being used. Right, we're going to switch over.
So what you're seeing here is a portfolio. This is a portfolio of buildings. This owner has 42 buildings in their portfolio, around about $14 billion of commercial real estate that they own. And so we're going to start our journey to the test tower here with this story. I think it was once quoted, necessity is the mother of innovation. So we're on this building here, which is houses about 3,500 people. It's 650,000 square feet, 37 stories. And we were a part of the journey in the construction process. And we got to the end of the construction process. And like a lot of buildings that are built even today, the handover and commissioning of that building is pre-internet. So if you think we are 18 years into the internet century, the building and construction industry it might be crawling. It definitely hasn't finished high school, put it that way. So we were on this project, and I'm going to click into the platform now and show you what we ended up producing. So I'm going into the digital twin. This was one of the first buildings, I believe, that was built on the platform with Microsoft. And I can, with my finger now, just toggle the building. I can use 2 fingers to look at various aspects. And what we've been able to do is I can search for any device, an IoT device, a static piece of data, and at the click of a button, I can find. So you might not know what a VAV is. A VAV is something that sits behind those air conditioning boxes you can probably see at the top of the ceiling. And you can see here we've got 657 of them.
So what on earth did people do before this? How did they?
Good question. Well, if I wanted to find something like this now, I would make a few phone calls. I'll be lucky. Hopefully, fingers crossed, it's in one of those ring binders. But that was maybe a few years before. I'll make a few calls. I'll go and speak to someone. And hopefully, fingers crossed, I might be able to find where it is. But with this, I can quickly go here. Incredible. It will find it in the building for me. There it is. There's the green dot of the device. And all of the important information, the critical information about that asset, that device is there. Its history, its warranty period, its replacement costs. I can even go and find, I'm logging in through the Wi-Fi here, and this building's on the other side of the planet, and I can, through a single pane of glass, it doesn't matter if it's a Schneider system or a Honeywell system or a Siemens or Johnson Controls system, it doesn't matter. I can, through the single pane of glass, find the data. I can also look at trend logs. So I can look at what the history was on that particular device and see what might be wrong or right with it. And again, this is just, you can change the date. I can look at it the last month and it will change for me. So it's all there at the click of a button. What's important, I think, here is that it's a fundamental shift for the way in which the interaction between contractors and equipment suppliers to the built world will work. Now the information stays with the digital twin. It doesn't go with the elevator company or the supplier. It stays with the building. So when I sell the building or I buy a building, all that information is there. And I will show you in a moment what we've done with the innovation tower, where some new innovations. And right down to the things like, all right, well, I want to find what the material, the operations and maintenance manuals, the warranties and so on. So that's where it started, Sam. I thought before we go and look at the test tower, I'm going to go back, parachute back out to the portfolio and go to another asset. This is quite slightly smaller. It's about $100 million in construction cost, 24 stories. And I'm going into the building process because there's two ways to create a digital twin. The first way is to use the current way we create buildings and infrastructure and just log in here and use the supply chain. So all of the contractors, the subcontractors and the consultants, and supply them with better technology that allows them to hand over not a roll of drawings and lever arch files and some USB sticks and some even CD-ROMs. You wouldn't believe it, but they're still getting handed over. This was practical completion, so when the builder is finishing their work was on the 17th of December last week in Sydney. And the owner can see right now, he's got 24,766 individual static and live assets in the building. So
and the timeline at the top, is that?
Yeah, so the timeline at the top's a live timeline, so he can see where he's up to in terms of completion, so we can link payment and progress to that completion.
So then is the digital twin built along the way?
Yes, the digital twin's built along the way, and what we're working on with our partners is to make sure that the owner can see the real-life digital twin as it's being built. So if it is not complete, well, that's because it hasn't been built yet. Yeah. I want to take you over to the Innovation Tower. We're really proud of this project, and maybe to give you some context here, we selected to work on this project with ThyssenKrupp Elevators because of it being an innovation tower. And it will always be an innovation tower for its whole life. So it's an opportunity for us with Microsoft to demonstrate what's possible today and to try and make the impossible possible in a situation where you can take your owners and clients too.
And for those that might not know, one of the things that's interesting that ThyssenKrupp has done in this particular tower is they have a new elevator that can not just go up and down, but sideways as well. So it's on magnetic tracks, and so obviously that's important to model.
Yeah. So the first step in the journey is to take what you saw on the screen there and bring in the information. So there's three bits of information. There's the asset registers, and today there's nothing stopping a contractor or not by holding down the Z key and it being the VAV. So there's no naming conventions. That can be pushed through the platform now. All of the spatial information, so the geometry and the live information, then is in the model. Whoops. And then we can go into now, okay, well, what does this actually mean? So as we get into then their portfolio, they've got buildings like the other group that I saw, and we now have got the new interface, which is on the Digital Twins platform. And I'm just simulating here a problem. So we've got a problem, there's a problem with the temperature in level 4, and it's above the threshold. So this is simulating what a facilities manager would do. He's going into the model now, and he's checking what might be going wrong here. So he's found the VAV device, all of the information's now come up, and he's going to look at the trend logs, maybe some of the live data, and make a decision on what to do. So what you'll see in a moment is he can diagnose the problem, and he could be on the other side of the world, and can diagnose the problem, and he can send out a work order. So the work order is coming from the platform. But before sending out the work order, let's look at the maintenance manual, which is there at the click of a button. Let's wait for him to... He's a bit slower than me. So now that the work order is being produced from the platform, and we can issue some statement around what needs to be done. And I'm going to assign it to one of my most trusted people, Jordan. He's a good guy, and he's going to come and fix this for us. So we're going to toggle now to the interface on his mobile phone. So he gets an SMS or a notification on his phone, and it's a work order which he's about to go and execute. Now, I might just pause here just to sort of talk about this. So what we've done on the test tower is our own unique QR coding on all significant assets. And when we get involved in the construction of new projects, we work with the general contractor to make sure that when as part of their commissioning and handover that these QR codes are on key assets. And what that does is that it allows the the person coming off the site, be it a contractor, he can use the QR code and immediately he can see where he is in the model, wayfind to the issue. And then, importantly, there's some training that might give them some prompts to say, well, this is what you need to do, or this is what you should do, and then we'll get the work order complete. Now, all of that history, when he came to site, what happened, is all captured in the twin. This is where it really gets exciting. Once I've got the twin, I can start to look at a marketplace. So what you're seeing here is an app store for a building. And we're working with groups like KPMG and with Microsoft to build out apps that can flood to the phone for an occupant or for a visitor, for a tourist. And we're going to look at a few things today. I'm going to look at emergencies, temperature control, and blockchain, which, as Sam mentioned, on the multi-elevator, we've been able to demonstrate a world first, we believe, in being able to pay through a digital wallet on the blockchain. And it's all been made possible because of the digital twin platform. So let's look at temperature, giving the ability for an occupant to move temperature, but the integration is quite easy now because the twin gives it the ability to integrate. What you're seeing here is a workflow of events through the blockchain because we've been able to digitize the contract. So the contract is now being digitized. It can show uptime. On the right-hand side, you're seeing uptime, and payments are being made without, just in the system, without having to have a major transaction occurring.
And that helps prevent falsified records.
Correct. Yes. Yes. So complete transparency and visibility. And lastly, with access, so giving a QR code or similar, I can then get an understanding of who's in my building, and then by installing some sensors, we can see where people are in the building and what kind of issues might occur. And in the event of a disaster, a fire, as an owner, I can see that who's evacuated, or maybe they haven't evacuated. And we're really excited about this, and it's something that we know we'll be working on more with you guys in the coming years. So thank you very much.
Excellent. Well, thank you so much for the partnership you're doing. Doing amazing work. That's a great example of a digital twin in action and where you need it. You'll be hearing a lot more from us as these capabilities roll out and we move towards general availability. But I encourage you to check it out. We have some great talks this week. You can see all of them here. We have talks from everything from IoT Central to our platforms to device provisioning service, Edge. There's even one tomorrow that I just wanted to call out. It was under embargo. We hadn't announced the name Azure Digital Twins yet. So it's actually on Wednesday over in Expo Theater number 10 that'll cover digital twins in detail. Join us in the immersion zone tonight at 6 p.m. We're going to be giving away some of our favorite developer kits, the MX chip, which will help you get started really quickly with IoT Central. It takes about 30 seconds to connect it, and away you go. And please do evaluate this session. So we have 2 minutes for questions. So what brave soul wants to go first? Or are you full? Yeah, come on up to the microphone so folks can hear you. You didn't know you were going to have to do that, did you?
On the digital twins thing, there was an option for cities.
Yes.
Do you have like certain cities already modeled?
No. It's more that it's an extensible platform, so that if I was a city and I want to be able to use it, I can. Okay. So, yeah. Part of what's important about the digital twin system is making it not just a runtime environment, but to make it an incredibly high-scale one that you could expand to those kind of scenarios. So, if you didn't have a question, or if you think of one later, we're at the booth in the expo hall. We have a section on digital twins. We have sections on all our technologies, and we'd love to meet with you, hear from you, and see about what's going to be next. So no other questions. Thank you all for coming. Appreciate it.